The addition and subtraction, multiplication, and division are the four main operators. They operate on different kinds of entities in the whole of mathematics. They operate on numbers, they operate on functions, on matrices, vectors, and so on and so forth. The result of this operation is dependent on the definition of the operator. When we use the addition to add two numbers, what we expect is the addition of those two numbers as the result, and that is because of the definition that we learned in elementary school. The definition in mathematics determines what is the result of an operation is, and in the case of the derivative, it's a new operator. It operates on functions, and the result of this operation will yield the slope of the tangent line and at a specific point on the curve representing the function. So a function has a curve representing it. We plot that curve on a coordinate system. This curve is made up of different points, and the derivative is supposed to give us the slope of the tangent line on each of those points. Now, a tangent line by definition is a line in which it touches the curve in one point and one point only. So we've got a problem here, because to find the slope of a line, we are using the rise over run formula. y2 minus y1 over x2 minus x1 will give us the slope of a line. Now y2 is the y coordinate of the second point, and y1 is the y coordinate of the first point. x2 is the x coordinate of the second point, and x1 is the x coordinate of the first point. So we have to have 2 points for us to be able to extract the x and y coordinates of those 2 points and plug them in the rise over run formula and get the slope of a line. But by definition, a tangent line is a line in which it touches the curve in one point. So we only have 1 point on that line. So how are we supposed to find its slope? The idea is to introduce another point on the curve. This other point is at a fixed distance from the first point. Let's say it's at a delta x distance from the first point, and that first point is located at x naught on the x-axis. The y coordinate of the point P is going to be f of x naught, and the y coordinate of the point Q is going to be f of x naught plus delta x. In this case, Q is our second point and P is our first point. The main idea that we use to find the slope of a tangent line at the point P is for us to introduce a new point Q. This Q is at a fixed distance from the point P, and we then plot in the passing line passing through the point P and Q, and we can then go ahead and find the slope of this passing line. The slope of this passing line is then going to be an approximation of the slope of the tangent line. And as we make the distance between the point P and the point Q smaller, our approximation becomes much better. And if we made the distance between the point P and the point Q goes to 0, our approximation will be an approximation no longer. It will be a precise estimation of the slope of the tangent line.
Only one headphone works.
Oh,
This one doesn't work.
that's great. That's the one. Sad face. My headphones don't work.
Only one headphone works.
Oh,
This one doesn't work.